have started the recording. We are on.
Cool.
So if you guys have to leave really early, or I know some people are coming in a little late, it will be recorded so that you guys can check it out afterwards. I'll send an email link out to you afterwards.
So on the download page, I just went in and hit download and picked Windows 64-bit. Most of you should have that. If you don't, you probably know. If not, try the 64. If it doesn't work, try the 32. It downloads as a zip. There's no real installer. You can open it up and just extract it. All I do is grab this and throw it on my desktop, and it'll extract. It's going a little slow because I'm in a virtual machine, just to show you guys this on Windows. If you're not running Windows and you're running Linux, it is a little bit of an interesting install, which it does take a little bit to get the file type associated and whatnot. I won't show how to do that because it's going to take up a lot of time. Probably doesn't pertain to anybody. And if it does, you may know what you're doing already because you're already running Linux. Sorry, it's
Once
going
you
so
guys
slow.
have some stuff downloaded and you know you have it on, if you want to give Ben some reactions using those awesome thumbs ups.
Yeah, I can see those. So just shoot them out there if you got them.
Hardy balloon.
Mine's going real slow, and I just want to show you. So when you open up the folder, you'll get these. You can open up the exe right away. And if you're trying to open the file that I sent out, you will have to navigate to this folder and just select this. So you open it in a new program. Another way you can do it is just opening processing. It may not work because it's still transferring. Okay. So once you get it open, I may be ahead of you guys. If I'm ahead of you guys, let me know. Just shoot it out there in chat. This little prompt screen, you can just uncheck that and get started. From there, it's just file open, and you can open wherever you downloaded that GitHub folder. I'm going to shut down the virtual machine just so I can save some resources and work from Linux through here. Have you guys got it downloaded, installed, well, copied over, and do you guys have the project open at all, or am I too far ahead of you? You got both? Cool. Have you got the project open, just like you see here?
Remember to feel free to use those reactions. If we see that we have a couple people who have started it downloaded. So we're going to keep going in a moment.
So the cool thing with processing is because they're in the same folder, if you open one, it'll open them all in little tabs like this. So the main one is Light Show. The beat listener is a little class file that we will create, but I've just added the file so it's easier to make. So you can open either one, but Light Show is probably the one to open if you want to just get situated with it. or I should say just for best practice. That'd be the better word. I can. How's that? Is anybody still trying to get this downloaded or opened? All good. Cool. You got it. It's 3 people. If you are just here to follow along and not really do it, just let me know. I have no problem with that. You guys can kind of see how I do it. And it's not something that's super complicated to code if you're not super strong with it, and that's why you're holding back. Just saying it's really easy to follow, and processing makes it really easy. This is something that I've been working with since grade 10. So quite a few years, and it is the main Java IDE that I started in. So when you go from something like this to NetBeans, it's like, oh.
It is 3 a.m. for Dilpreet, so I think we should get started and we'll start moving along.
Yes. Sorry. Alrighty. So we're gonna have to go up to the top here to sketch and import library. And I've already got them here because I was testing it, but we'll go to the very top and do add library. And it gives you this nice little manager, which you can type in, or right here, you should see Arduino. We won't use that one yet because we don't need to implement it yet, but we want to look for something called minimum. And I will put it in chat so you guys know what I'm looking at. So once you guys have found that, all you do is just hit the install button. It'll automatically install the latest version, and it may just take a few seconds, maybe a minute. And I know through the program that I went through is we never really did anything with audio. Audio has always been something that like I was wanting to put in applications. I actually did it for one of my Java final projects. And obviously this one incorporates audio as well, but this isn't something that we learned in class. So it's always cool to see how you add music or add background tracks or sounds to your projects. So once you get that, we'll go and we'll close that. And right here, I've added some comments in here so that it's easier just to organize everything. And we'll go ahead and we'll type in import. And we want processing dot serial dot and then the little star, which is just shift 8. That selects everything, that every sub library of processing serial. Then because we got minimum, we have to import it. So we go import, we do ddf dot minimum. And so that's all. DDF is just the identifier, and that's all the packages under minimum. But there is one subsection that doesn't get incorporated, and we can actually copy that and paste it. And now right here, we want to do a dot and do analysis. Sorry. Yes, I just saw Virginia's comment there. It's terrible. I hate commenting code, but it is best practice.
It will save your butt time and time again. Trust me. I did have a teacher who told me that I made my code look like spaghetti. So I started sorting it out with comments, and it definitely saved my code.
Yeah, and like it's not, the comments aren't for you, it's for the person looking at your code. And I'm sure you guys have heard that before. So it is in best practice to do that, because half the time you could look at code and you have no idea what it's trying to do. Alrighty, so underneath here, we actually have to create classes, instances of each class, sorry. So we did minimum, so we'll do capital M minimum, and then all lowercase minimum, and that's the instance name. And then we'll do audio player with a capital A and capital P. And for its instance, we're gonna do song. Underneath, we're gonna do beat detect, because we're actually doing analysis of each track. And then we're gonna call that beat. Underneath it, we have a class up here called beat listener. So let's add that. And then we're going to call that BL. But because nothing is in this file over here, it throws an error. So let's go over there. And underneath here, we'll just have to do enter. And we want to do class beat listener implements audio listener. Just like that. We can do enter, and then you want to open it with curly braces. I'm just reading some comments there.
Pretty funny people. Pretty funny people. Yeah.
Just see if you guys are keeping up. So in here, we don't need that space there. We can do private. Oh. And then beat detect. Because we have two beat detects, we need to make this one private so that it doesn't interfere with the other one in the main class. And then we can do beat. And then we want to do private as again, and you do audio player. And we can make this one called source. So this is our source audio. Don't worry about them being underlined here. They just aren't used yet. From here, if you guys are familiar with Java, it's a little bit easier to make it, make constructors and whatnot in processing. So all we do is beat listener. Ooh. Because that's the name of our class. And then we want to do beat detect, beat, comma, audio player, source. And that's passing those two values in, and we can open that up. So to assign this, it's really weird how this class works, but you just do this dot source equals source. Same thing is, actually we can copy that. And get rid of that. So this dot source dot add listener, this. And then we go this dot beat equals beat. And all we're doing here is we're taking the values that are passed in, which we'll use in light show class, and assigning it to this class so that it can be used locally in just this class itself. So we can actually go down here, and we want to open up a void. So void in this IDE opens up a function essentially that doesn't return a value or doesn't have to return a value. So we'll do void and then samples. So we'll open that up and we'll do a float array. And I called it SAMPS. It's a really lazy naming scheme. And then we can open that up.
Oh, we're having an issue with somebody not having beat detect.
All right. Did you add the minimum library? You got that installed? Beat detect's not found. Did you get that over here as well? Did you have the beat detect not found on this? Okay. Try going up to the top to sketch and import library and then go down to minimum. It'll import all this useless stuff, but it'll at least give you an idea, and you can actually get rid of that because it's double implementing it, and see if it's found there. If it's still not finding it, yeah, just save the file and close processing, open it back up. Is anyone else having that issue, or is it just him?
We can also have you share your screen and
Yes.
we can check out your code and see if you're missing anything as well. I find that helpful when I do other nights. So I have set it up so multiple people can share their screens, just in case you would like to have the class take a look at the code. It's always fun.
Yeah, a lot of the time it's because minimum's not being found.
And also, if you share your screen, Ben can actually take over your screen, like your computer, and look at your code that way as well. It's a really good way of being able to sort of, what's that called? Debug things.
No problem. I guess I skipped over this. The main thing that got me into making this kind of program was my first year Arduino class. It's an IoT class. I kind of took that with a grain of salt and made it just an Arduino class. It didn't have anything to do with IoT, but I wanted to put on a show. And if you guys have ever seen those light shows of houses during like holiday season, like Christmas or Halloween and whatnot, I like them. But my take was, after doing some research, they're all manually done, and it's done like a timeline of a movie, and you can do. Oh, you're in it for the rating. Yeah, sorry. Yeah, so it's done like a timeline of a movie if you've ever edited a video or anything, and different effects are done as the song plays out. I didn't like the idea of having to manually do all this effects chaining essentially to do a timeline. I wanted it to be reactive, and I didn't want to have to do it for every single song, like make a chain for every single song. So I wanted it to react in real time. So I made this. It's made out of just like insulation foam. And Virginia, I think if you remember this, it was a bit big, and I didn't know where I was going when I was making this. So I made it. My mom painted it. And these are just little snippets of when the lights are all actually on, and these don't have to be on with the white lights that are above. It is roughly cut because all I used was a knife, but from a distance it looked fine. When you're up close like this, it looks pretty bad. And little LEDs. So I used a hot nail. So I heated a nail up to poke holes in the foam for these little LEDs to go in. I used L wire. If you've ever heard of L wire, it runs at a really high voltage but low amperage, which I'll show you on the behind picture, the little converter for it. And it does this like little rope, kind of does like Christmas lights rope around. That was kind of my I hope. You can see it lit up well in the dark here. You can see the blue, like a little rope going across. Perfect. Good news. And even better in that shot there where there's not too much. There is an LED strip as well. That's just an RGB strip that's shining onto the house. And different triggers trigger different lights. So red, green, blue, and yellow all had different essentially bands of the audio. So where you have a kick drum, the red would go on, or you have bass. If you have a lot of bass, that's where the LED strip kicked on. But it didn't get the colors from the bass. It got the colors from kind of the high end of this track. If you guys are familiar with music, like your treble, your high end where you hear the really high pitched sounds, that's what was making the color different. And there's like a cool shot of the LED strip off, but all the other lights are lit up. This is behind it. So this is the wiring for it all. And it did take quite a few hours. This is actually I would say 75% done. There was only one Arduino in this picture. I actually added a second one because if you guys have heard of addressable LED strip, where each pixel can be a different color, I ran that afterwards, and it's not in these pictures, unfortunately, but I had to run a different Arduino because of the code that it was running. So this little board down here, I don't know, there you go. This thing down here is what was doing the voltage jump from 5 to 90. And that comes with the LED, or sorry, the L wire strip. So I just wired that in to trigger, and it had a button on it. So it would only work when you press the button. All I did was just solder the leads together so that it was always on. And yeah, it's a bit of a rat's nest. It used an Arduino Mega. So that was one that I bought just from Amazon, and it gave me a lot more ports than what normally comes. And that's how I was able to do that. The program
it doesn't have to be like Arduino brand.
No,
It
yeah.
can be like the Elegoo. Like I know that I have like an Elegoo kit. They're much cheaper than the Arduino brands, but they do work as well.
Exactly. I don't know if my audio is going to work, and the quality is kind of low, but this is a little snippet of it. So yeah, it was pretty cool to make, and when it was finished, it was really cool to see. This is before the bottom was painted and everything. And I did have light strips going up the side that did volume, and that's where so you couldn't hear it, eh? I can try and play it close to my headphones. Here, let's try this.
If you turn your volume all the way up, you can hear it.
I can try doing this. So yeah, that was a little video that I had of it. That wasn't the fully finished version, but with that song, that was kind of the most tuned song that I had. There's a little picture that was actually me in a classroom in Georgian. Don't know. I forget his name, Virginia, but yeah, this Virginia was pretty much somewhere around here.
Yeah, I was like, there's Charlie, I think I'm either sitting on the opposite side of you, I think.
Yeah. So this was just me in class, and I had my Arduino there, but this was the program that I wrote for it, and we'll have something very similar looking. But yeah, so that's pretty much what I made, and we're gonna do a little bit of a version like that, but nothing as intense. It's a bit interesting. These are all the songs that I had. So they just loaded. I did have to load the song into the program, but I didn't have to do anything for it, except if you wanted to fine tune it, I had little values up here to let me do that. If we get back to the code though, now that we're up and running, in this function here, we just want to do beat.detect, and we want to use source.mix. And what we can do is actually copy that, because we're going to do something exactly the same. But if we want to do stereo analyzation, we want to do samps L, and then the same thing, float array samp R. That's it. That's the only difference. So that whole class is done now. We can go back to the light show, and we see that that's no longer an error. And to do the analysis, we'll need something called FFT. FFT is just a way to analyze a spectrum, an audio spectrum. And Audacity has an FFT plotting chart, but we're going to make our own. And it's just for visualization to see kind of what bands are peaking the most. And I'll get into the whole band selection afterwards for each channel. So on my house, the house that I made, each color had its own band. And then that'll make more sense later on when we're actually looking at it. But just remember that each color was its own band. So down where we're going to establish variables, we need to make a Boolean. And processing makes this really easy. You just type Boolean and you can do play song. So camel case, you don't have to, but it's best practice. Then comma and song loaded. And you can do equals false. So processing lets you, I don't know if like IntelliJ or NetBeans or Eclipse or something like that lets you stack variables like that. yes, best practice. But this lets you stack variables and make them both false. Below it, we're going to do a float, and it's going to be kick, snare, and hi-hat. So these are just the 3 channels that we're going to make for this. Yeah, I saw that, Virginia. For this little project, we're only going to do 3 channels, and that can illuminate 3 different lights if we want to at the end. But for now, that just makes it easy. I do have another project that has like, I think it's 16 different channels. 2 of them aren't used, but and 8 of them are dynamic, which I'll get into. I'll show you the code afterwards because it gets really complex and we won't do that. But it's something that I've worked on since doing the house. So below that, we're going to do float and kick size. So this is just for the text that we're going to print out, or not print out, but draw. This lets us change the size whenever the thresholds hit. So whenever the light's going to turn on, we'll actually change the font size, so it's a visual. And then we do hi-hat size. Below it, we're going to do an int, and this is called kick band, and then snare band, and then hi-hat. Oh, no, we don't need to do hi-hat, actually. We're going to do kick trigger, snare trigger. We're not doing hi-hat because this minimum library actually has a function called dot is hi-hat or something like that. It might be something like that. It's not the most accurate function, but we'll just use it for now because it'll do more than the hi-hat, but it gives you an idea of something that's built into the library. And so we're going to scroll down, and right here, oh, sorry, we don't even need to do that because we already did that here. I have that mixed up. So we get rid of that. So in processing, I never spoke about this, but there's two void functions that come default with an example or with a new project. So if you do new, you normally do a void setup and a void draw. By default, this is set up to run Windows, like a windowed application. So in the draw, there would be everything you want to draw. In the setup runs once. So when you start the program, the setup runs once, the void loops until you terminate the program. So that's a cool way to think of it. Because this loops every time, it's constantly drawing over top of itself, but it's pretty intelligent and it will wipe anything that's overlapped. So you don't have to worry about memory leaks or anything like that. Thank you for those little notes there, Virginia.
Man, I'm a note-taking fiend, and that's one thing that I wouldn't remember in the future. And I think that's something that's important to remember with this, is that the setup is running once and the void is
Yeah,
looping.
I wrote them in this comments here just so that we understand it a little bit easier. But from here, what we're gonna do is, for better analyzation, just because you can't run it at 120 frames, or you may not see it at 120 frames a second, we're gonna run it at that, which is just frame rate with a capital R and then 120. Audio itself runs at a much higher sample rate per second, but printing or drawing these things out at 120 frames just gives us a little bit better precision. The samples over here, when we're loading samps into the beat listener, this is loading at the sample rate of the audio, but visually we just want to see it a little bit faster. Just because you have a higher frame rate on a lower refresh rate monitor doesn't mean you're not getting information quicker. You are, but if you got a higher refresh rate screen, then you can actually see it. From here, we're going to set the size of the window. So it's just size. And because I don't know what size monitors you guys are running at, I'm going to do 1280 by 600. I know the first laptop that I had entering this course was only like 1366 by 768. And that's the window size that I've always stuck with, even when I'm on 1080p. We are going to add one little value onto the size there. We're going to do comma and P2D. This gives us acceleration so that we can hit the 120 frame. It is a 2D program, so you're probably going to be able to hit it. It's not going to run super intensive or anything. Below that, we're going to have to do minimum. And we stated this was our instance of the library up here. So we have to do equals new minimum. And we can do this. So just because we create an instance doesn't mean it's being used yet. This is just one thing with processing, is we have to call a new instance. Or gets confusing. It's hard to explain. So below that here, all we're going to do is set the text align to all capital center. We don't need to pick global font because we're just going to use the base one. I did change it for my project. I don't know why. I think it was just force of habit, because that's what I was taught in high school, is the default font isn't pretty. We're underneath it. I didn't have that originally, but just for best practice, we're going to do kick size is equal to 16. And this sets the text size to 16. And that's just what I found to be pretty comfortable. And we double that for whenever we're going to show the trigger or show the light triggering. We can do snare size equals 16, and then hi-hat size equals 16. So that's it for the setup. We'll go down to the draw now. And remember, this does it this loops until you close the program. So if you're ever gonna make an application in this, if you're gonna draw any rectangles or anything, you can draw them in the setup, but it won't be continuously drawn unless you put it in the draw. So if you want to make like a rectangle go across the screen, then you'd make sure the background is like black, and then I missed an N. You could do rect. This isn't part of the code, but I'm just drawing it out there. So this is how you make a rectangle. You can set it at coordinates X and Y, and then it's 100 by 50. So that's actually how you would draw a rectangle. And I can show you by running it that it just draws a rectangle like that. Yeah. So if you wanted to make it go across the screen, because the background's always been set to black every time it loops, you could constantly do something like, just to show you guys, let's do this. Do kick size. So it's going to put it at 16 on the X. And then we go kick size +1. Oh, let's do equals. Yes, you can make games in this, but there you go. It's nothing special. It really isn't. And it will go off the screen because there's no bounds. But yeah, that's just a little way if you guys want to make a game. I have made games in this. For some of my classes, I recreated Five Nights at Freddy's. So that was pretty cool. And that was a really big game. It ended up being like a gig because it couldn't compress anything. But yeah, that's just a little cool trick. Underneath here, where we're going to draw each button, we're going to do a fill of 255. So this is white. Then we're going to do text size because we haven't globally set text size yet. Jeez, can't type. And we're going to do 16. Just to keep it all uniform, it's always 16. Doesn't have to be, but that's just what we're going to do for today. Underneath it, we'll do text. So like we did for rectangle, we're do text. And we want to do this play song. So that's what the text is going to be. We do comma, and we've got to say where we want it. So we do width minus 200. So it gets the full width at 1280 and minus is 200. You could set it specifically, but this is just the way that I've always been doing it. It does a height of 10 pixels, and then we do 150. So if you'd like, you can copy that because it is a lot to type. Underneath it, we can do stop song. And instead of minus 200, we just do minus 100. Saves you from having to type out everything else. And it just nudges it over 100. Underneath it, I do have 2 songs in the data folder. So if you notice there is 2 songs here. There's just 2 songs I loaded. One has a really good kick and snare. The other one is the actual song that I used in my presentation, which is just a Game of Thrones remix. So here we can do text, and we'll put the name of the song, which is Thrones. And what we can do is grab all this again. and we want to make this 60. That nudges it down on the X, or sorry, on the Y, so that it just puts it below the play song. And we can even add that other song that I've got. So let's copy that. And it's called Dead Chunk. And we want to make sure that it doesn't overlap, because if we run this now, these two are going to overlap. So I put that at 120. Alrighty. So now those are there.
If you ran that right now, would it show anything?
Yes, it'll show the labels. So like my program was over here, where I had the songs and whatnot here, and those were songs that I had prepared for my presentation. If we go here, we can see that the songs are loaded. These don't do anything, but those are eventually going to be our buttons. Don't worry about this when it closes out. It's because you didn't hit stop. From here, we set the fill to white. So we want to go back to black, which is just fill 0. You can do full RGB values. So if you wanted, you could do 0, 0 like that. But it's just easier to do 0. Less typing. Less typing to me is better. It's less that you can mess up, and that's a better thing in my books. So below that, we can actually exit that out. No problem. Yeah. What I'll do on the GitHub page is I'll put the final project in there, so that if you want to take a look at it working and see what we wrote out, if you can't get it working or anything, you can kind of see what I've got there. I'll put that up there. That way the empty template and then the final project's there. Yeah, enjoy the lecture. So here we're going to do stroke, which is an outline. And we're going to make it, we're actually going to use the RGB value so that it's red. And I'm only doing this because I have a red, a green, and a blue LED to my right here. So when I show you the camera, it lines up with what's on the screen. So below it, we're going to do rect. We're going to do 550, 220, 120, and 60. Sorry, I was looking at the wrong line. This is actually 360. So that would be over to the right too much. So just make sure that we change this to 360. And what we can do is copy this for the snare. We can paste it, but we want to change it from red to green. And we want to change this to 550. And we can paste the same thing for hi-hat. Make sure we change this to blue. And this guy gets changed to 740. Now we reset it back to black, which is the stroke, so it doesn't get shown because the background is black. So we just go stroke 0. So in here, what we'll do is fill, and we'll change this to 255, so it's back to white. I know it's a lot of flipping back and forth, but because we're drawing different colors and whatnot, we pretty much have to set it. And it doesn't take up much processing time whatsoever. No pun intended. So we'll do text size. And we'll use the kick size value now. So whatever we set kick size to, it'll always be drawn at that size. That's where we get it reacting to the music. And we'll do text. So we'll name this kick. This is at 420 and 260. these are just values, X and Y values that I found to draw it sort of centered the way, just for comfort. You don't have to draw them at these. It's just for a demonstration, I'd say.
Is that something that you would tell the students to like maybe like play around with once they finish the code? They can like see how it moves around the page?
Yeah, so what we'll do is, my mouse is glitching here, but I'll stop that. So now we have boxes, which is what we want, and we see the word kick. So these values here are actually going to change where that kick is placed. So if I do something like 100, now it's over here. So it's always from the top left to the bottom right. So the 0, 0 is top left. And 1280 by 600 is down to the bottom right. So it's 260 pixels down and 100 pixels over. Now, it may look a little bit more, and that's actually because the text align is centered. So the box itself that it's drawing out is a little bit bigger than the actual text itself. So that's where these values just get it centered in the boxes there, and we're getting there. I have the boxes colored just to my lights. I don't think I had any boxes. Yeah, but you can see, this is a good example. I just realized you can see the text here is a different size than these words, and that's because they're active right now. So that's what it'll look like when it's active. They'll actually get bigger and then shrink down. And to make them shrink, we have to do something called a constraint. So we do kick size equals constraint. And we want to do kick size times 0.95. Oh, 0.95, my bad. 0.95. Struggle to get that one out. So that's the rate at which it shrinks. And we go from 16 to 32, which is confusing because of the way it's laid out, but we're actually going from 32 to 16. So 16 is our regular font size. 32 is when it's big, so it doubles in size, and then we shrink it by 0.95 every time it loops. So we'll take this and copy it just because it's tough to type out every time. And we'll change this to snare size. Then we'll change this to snare. We can grab this, copy it, and paste it on these two. And then we have to change the location for this, which is 610. We can copy it again. I think my mouse is dying because it keeps stopping on me. And we can change this to hi-hat size, copy that, change this to hi-hat, and this value to 800. Went a little quick there, so I'll let you guys catch up. We're essentially just drawing out those words, kick, snare, and hi-hat, and setting it up so that it grows when they're triggered.
Does anybody have any questions up to this point?
Everyone
it's been pretty clear, but like
along?
if there's questions, throw them out there.
I know this is slow, but we do kind of take it a little bit slower when you're learning this newer syntax. It's not exactly a new syntax, but it's a different way to type out Java. Has everyone gotten up to this point? There it is, open there for you. First the cat and now the dog. Did you figure out what you're missing there, or did you need some help? Okay, cool. So I'll jump back to here. Is everyone good so far? Does anyone need help with anything, or am I good to go on? Yeah, no problem. Good to go. Cool. So at the bottom here, you see the curly brace, and this is still part of the draw loop. So to get out of it, we just go enter, enter, and we can create a function down here. And this is something that I created in, I think it was grade 11, when I was in grade 11. So that would have been 2014. And processing doesn't have a way to create a button or anything. So in order to do that, my teacher at the time and I came up with this little function. It's actually a Boolean because it returns true or false. And we called it mouse in rect. And we used this for a lot of the games that we were creating and everything. And everybody in the class was using this. And it was all because of, like I said, I made Five Nights at Freddy's and I needed a way to make a click, like to click a button. So we came up with this, and it gets a little bit confusing. Just follow along. So we do int x, int y, int rect width, int rect height. Oh, wow, I could not get that whole bit there. So we do open that up, and essentially what this is we're passing in an x value, a y value, the width of the rectangle that we want to be able to click into, and then the height of the rectangle that we want to be able to click into. So then we go if mouse x. So this gets the location of the mouse at an x axis is greater than x. And is a way to do, and sometimes it's like two pipes like that, or that sometimes that's or. But and is the way to do if this and that. So then we do mouse x is less than x. So we're making sure that the mouse is between the x points plus the rect width. So that way it's between our x that we passed in and the farthest x. So it's within the rectangle. We do another and mouse y is, it's kind of set up the same, is greater than y. And mouse y is less than y plus rect height. Should be fine, yeah. So it's an if. Just making that mistake there, I actually realized we could shrink this down. From here, we just do return true, like that. And then we can do an else underneath, return false. Look at that, I'm making improvements to my code from 2014. All I had before was just, it was in brackets and it was like 4 extra lines of code, but it's really just 1 character each. Yeah, I like your little thing there, Virginia. That's cool. Alrighty, so now that we have that, we'll actually put this into use. So we go back into the loop, and right here. So we'll do another if mouse in rect. So we use this and we got to pass in values. So we want to do width minus 200, 60, 150. You'll notice that this is where I believe, yeah, play song. So that's where that is. You could copy it right in, but that's the coordinates for that rectangle that we drew. Or it's not a rectangle, but it's where the text was drawn. And we do and mouse pressed. So this checks to see if the mouse was clicked. It does have that, but it doesn't have a way to make a button. And we do and then play song equals false. Oh, we got to do equals equals. Some IDEs are equals false for Booleans. This one is equals equals. We'll just open that up. So we'll load a song now. And it says song equals minimum dot load file. And then we'll navigate to, we gotta put in quotes, data, because that's where the files are. And then thrones.mp3. So that's where that file is, right in the data folder. We have to specify the bit rate, which is just the default is 2048. And then we can close that off. So this value is actually what gets passed into the samples here. So if you're wondering what this was, that's the 2048. Below that, we can do kick band equals 4. For different songs, you can specify what will trigger when there's a kick. For this one, I just found 4 to be pretty easy. The kick trigger is going to be 140. So that's the volume level, or the value that it has to hit in order to essentially turn on the light. Or in our case, it's just going to make the text a little bit bigger for now. Underneath it, we're going to do snare band is equal to 9. And snare trigger is equal to 120. So this is just loading the song, and these are the only values that I really fine tune. It's the only thing that you really need, and you can do it pretty quick just by running the program. I can, at least. I'm not saying that you guys can do it quick, but once you kind of get an understanding of it, you can do it pretty quick. From there, what we're going to do is song loaded equals true, because we've loaded a song, and if we hit play without loading a song, it will crash. So this is just a check so it doesn't crash. We can do fill 25500, which turns it red, and we'll draw a rectangle. And what we'll do is we will go and grab this. My mouse is doing the. There we go. We'll grab that and we'll just throw it there. That way, when we click it, I'll save this and load it. I'll show you. That way, when we click this, it does a red rectangle, just to show that we clicked in that box. So I got an error down there, but I don't think, I think it was fine just for me clicking over and over and over. Unless I spelled that wrong. Oh, that looks good to me. So we'll do the exact same thing for the other song. We can copy that and paste that. We will change this to an else if. And for formatting, you can bring that up there if you'd like, just so to show it's the chain of ifs. We will change this value here. The 60 goes to 120. We can change this to dead chunk, because that's just the name of the song. And I believe all those values are the same. except for this right here. So that just makes sure that the rectangle gets drawn below, and we'll show that it goes red. Alrighty. So I'm just gonna get rid of that space. Where we're creating the audio player buttons, where it's play song and stop song, it's right here. What we can do is if mouse in rect, and then we got to pass in some more values. So we go width minus 100, 10, 150, and mouse pressed. And play song equals true. So this is just making sure that there's a song. Oh, we had to do equals equals. I always forget that because it's been a while since I've did some processing coding, and we'll open that up. From here, what we'll do is we'll draw a rectangle, and we'll do width minus 100, 10, 150. You could copy it from there, but I just typed it out. I forgot about that. We'll do song dot close, 2 brackets because it's a function of minimum. Jeez, forgot about it. We'll do song. Oh, sorry. Play song equals false. So this one's actually just 1 equals. That's where it gets confusing. And we'll do song loaded equals false. So it sets it back up that we can play another song once we hit stop. Below that, what we can do is an else if mouse in rect, and we do width. So this is now the play button, play song. So it's 200, 10, 100, 50, and mouse pressed, and then play song equals. You want to make sure it's not playing a song right now, so it's false. And then we append that the song is loaded. Make sure it's true. So from here, we're going to do the same thing as we did above, and we're going to do rect width. Actually, I will copy it from here this time because it's easier. And now we'll do song dot set volume. Doing this so I don't blow your ears. Just set it to 50%. Song dot play. You can turn it up if you want. You don't have to put it here, but I just doing that for my sake, or for your sake, I should say. Although you couldn't hear my audio before, so that might be for nothing anyways. So beat equals new beat detect, and then we want to pass in song dot buffer size, and then we're going to use the song dot sample rate. So creating a beat detect instance, it has to take the buffer size that we set, and then the sample rate, which I believe are actually the same value. Below it, we're going to use FFT. So that's just to get the analysis is equal to new FFT. And we're going to take that exact thing that we just wrote up here, copy that down there. Below it, we're going to do FFT in lowercase this time, or yeah, it was lowercase above, but we did uppercase here. Dot LIN averages. There's an S on there, it's plural, and we'll set it to 70. Below it, we're going to do beat.set sensitivity. And we're going to make this 40. 40 is a really low sensitivity, but it just makes sure that each band is over 40 digits, I guess. Go ahead.
You've got a spelling error on mouse pressed.
Oh, thank you. Didn't go pink. Thank you. So yeah, that just sets it so that it's a minimum of 40 before we actually see it on the screen. Below that, we're going to do BL equals new beat listener. So this is the class that we made. And then we just do beat song. So you got to pass in those values. Underneath it, that's the last thing of this is play song equals true. I know that's a whole lot there, but we only have to do that once. That's it. So that's essentially setting up the track to be analyzed, and that's how each function is, or each library function is used. That's the right word for it. So now that we finally got that done, all that does is play the song. So we can actually go over here. We can pick Thrones and we hit play, and I hear it. And we can hit stop, and it stops. So if you're at that point and if you want to give it a shot, go for it. We haven't drawn anything else. It's just simply playing the song and stopping the song. And if these don't have a rectangle for some reason, don't worry about it. It's just because we're drawing so quick. But yeah. So let's actually start doing some analysis of the song and actually getting something reacting. That was just getting the song to play. So from here, we do if song or play song equals true. So we're just making sure that it's playing a song. We're going to do FFT.forward. And we're going to throw song.mix. We're going to make sure the text size stays at 16. So we do text size 16. And then we're going to do a for loop. So for int I is equal to 0. Wow, if I could do it. And this is your normal classic I loop. Just wanted to make sure I didn't have anything different in there. You guys have probably seen that before. If you haven't, you probably will at some point. A lot of time you'll see equals to 80. On the screen size that we wrote out, 79 seems to fit, 80 doesn't. So we don't need to draw that extra one if we do equals. So in here, we're going to do a float b is equal to FFT dot get band. So this is where the bands come into play. And we're going to use that value of I. So then we're going to do if b is over 60. We're going to fill 255 0 0. And all what that does there is, if I pull up these pictures, see how the ones that are essentially the values above 60, they're turned red. So it's a good indicator of what's peaking and what can give us a decent reading for each band. Below that, we're going to do else fill 255 just to make it white. Then we're going to draw the rectangles. So it's I times 18. Then we're going to use height minus B, 15, and then B. It's an interesting way to do it, but essentially that just loops over and draws them out from the left side to the right, spacing them out by 18 pixels, that is. And then we're going to do text. So this draws what band is each. So starting from 1 to, we said it was 79, because 80. So we're going to do we're going to do I times 18. And this only takes 3 values, so it's height minus B. Oh. So what we can do is run this again, and you'll see when we actually load a song is we're getting that. And these are all the bands at below. Yeah, so that's just a cool visualizing way to see your music. We can load the other one. This song doesn't start out with too much. Yeah. So that's just drawing it out now. From here, we do the band selection. So we're just going to get out of that for loop, and we're going to go if FFT. I like to throw a little space there. I don't know why. It's just something I've done. We're going to do get band. And then we're going to use kick band that we specified before. And we're going to make sure that it's above the kick trigger. So it's greater than kick trigger. We are going to open this up, even though we're only going to put one line in here. And we want to just make the kick size 32. Oh, it's not a function.
Ben, is this something that you can push up to GitHub, like to get like where it is now? And then so that if people need to catch up or anything, they have all the code that you have currently and they can continue from there? Or is that a process?
I don't have Git right now, but all I can do is just upload that file. So what I'll do is I will just make this live. Sorry if I was going too fast. Yeah, it is a bit of a process. I know I kind of get carried away with it.
I do the same thing when I do it, and I was just like, oh, I'll push to Git. I'll try to push to Git, guys.
Yeah.
Thank you so much.
So there you go. You can go grab the live folder now, and that should have everything there. If you guys want the link again, I can throw that there. So now that you actually have this, it's really easy to catch up. As all you do is just copy, and we're going to change this to snare band and change this to snare trigger, and then change this to snare size. Then for the final one, because we're actually using the incorporated is hat. Yes, it's is hat, not is hi-hat. All we have to do is if, and then we do beat dot is hat. Then we can do hi-hat size equals 32. And that's it. So from here, you can just hit start and load a song, and there you go. These will start reacting. Now it's not perfect because it is just a really basic way to get the triggers to stop. So this one is probably a bit easier to see, and I'll throw my headphones up to the mic. So there you go. So that's pretty much it for just getting something to react. I believe I have this one. I can show you kind of what it looks like if you want to get it more complex. And by doing that, I see I have a whole bunch more, and I got to add more of these texts, and it gets a lot more complicated because when you start getting down here in that for loop, I've got to start breaking up the bands because I've only got 8 channels essentially to assign dynamically. So I've got to start breaking them up into 8 and appending them into lists. And then from the list, it gets essentially handed out to each one. I didn't finish this all the way because you'll see all these, the bands stay null. But here's a good example of what looks like when you get a whole lot. And I'll throw my headphones on again. Yeah. So it gets to be a bit intricate when you start adding things, and you can assign each of those channels to their own LED if you had enough ports on your Arduino, which you can definitely do with the Mega. So at this point, we're pretty much done with just getting something to react. We're getting all these to react. If we want to implement it with, yeah, psychedelic, yeah. If we want to implement it with an Arduino, there's a really nice library that Processing has, and I believe most Java environments do have a library. Processing just makes it really easy to add. We go add, and we want to look for Arduino. Just like we did with Minim, we select that, hit install. And you actually see that it says Fermata or Fermato. I don't know the pronunciation, but so that's the example that you want to use in the Arduino software, which looks like this. And all I did was go examples, and it should be in Fermata right there. It's included in Arduino, and you just go standard. So standard, you can do it over Wi-Fi. Have yet to do that, but I just do the standard Fermata. It's already loaded, so it's not going to do anything. You don't have to touch anything in here. You just have to write this to your Arduino. And I believe I can show you. Will let me do this at the same time? Maybe not. Let me try this. Let's see if I can do this. Oh, it lost my camera. That's why I can't find it.
Such is the world of OBS, constantly losing the camera.
maybe Zoom will let me do it now. Hey, there you go. So I don't know if it's small. I can throw it up on my screen if you want it a bit bigger. But right now I just have 3 LEDs on a breadboard. They are using resistors because it's best practice to do that. You can run LEDs straight to it, straight to 5 volts or 3.3, but just practice to do a resistor. All this is plugged right in, and what we can do is just upload this. You'll see some lights flash, and it'll upload. I did nothing to the code. And just in Arduino, you just select your board. This is an Uno that I'm using. You don't have to use an Uno. I think you I think you get a Leonardo in your kit.
Yeah, I think that's what we get.
Okay, yeah. And it's like the same thing. This one's just nice because you can take the chip out and implement it in your own circuit. You don't have to use the developer board anymore. If you got one of these, which I think you did, you have 2 LEDs on this. So if you don't have a breadboard, you could plug this in and you could use the red and the blue LED down here, right there. You could use that to essentially make this work. And I may do that instead, but I'll show you this, how I get this working. So at the top, once we've got the Arduino library added, we have to import it because it's not going to work. So we go import. It's cc.arduino. And then we do period.
We can only see your camera right now.
Oh, really? Oh, how about now?
Now we can only see your name.
Oh, how about stop share? Isn't this lovely?
If you hear cooing sounds, it's my cat. She's just gone into heat. I apologize, guys.
Can you see it now?
It should start sharing in about 3 seconds.
3 seconds.
It's seriously thinking about sharing your screen. There it is.
Oh, okay. Yeah, sorry. So we just added this, and I'll wipe that out and go import. And we do cc.arduino period star, so that selects them all, and then a semicolon. So that just imports that. Like we did down here, we have to create an instance. So we go Arduino, and then just Arduino, all lowercase. Did I not spell that right? Yes, I did not. I did not do it either time. That's better. When you spell things right, it works. So below here in the setup, we've got to add the initiating the instance. So we go Arduino equals new capital A Arduino. And then we do this, and we go Arduino.list. So you could write a program to have multiple Arduinos, and list is an array. So we're going to do square brackets, but we're going to select 0 just so it selects the first one. We don't have multiple. Oh, I forgot to do 2 brackets like that. Or parentheses. I don't know if you've had a instructor kind of go at you for brackets and parentheses and curly braces and everything, but Virginia and I did. So we do comma, and then we want to do the baud rate, which is 57600. And if you don't know what that is, don't worry about it. It's just the rate at which the serial connection over USB works. If you still don't understand that, don't worry. You probably will learn that when you do serial connections in the IoT class. From there, we don't really have to do anything else. Actually, for better practice, what we'll do is like you do in the Arduino IDE, you do your pin mode output. But for this one, we have to do Arduino. So we can actually grab this just for easier. Dot pin mode. So just like you would do in Arduino, you do pin mode, you have to do Arduino dot pin mode. And it's literally the exact same. So we can do kick pin. Now, we didn't specify kick pin up here. So what I'll do is I'll just hard code them in here. I'll do 10 because that's the way I have my breadboard set up. If you're just watching, you can just watch and getting through my example code. But if you're doing this, then just set it to whatever pin you have LEDs on. On this little 3, 2, 1 maker, it's pin 13 and pin 12 if you're trying to use that. So we set that, and we want to set that to low, or set as an output first. So let me do Arduino with a capital A output. And I'm going to copy this 3 times and set this to 11 and this one to 12. You can use any pin. That's just what I ended up using because it was closer to the ground at the top. Below that, we're going to do Arduino digital write. So very much like you would do in Arduino. And you want to set 10 to low. Oh, it's Arduino.low. Copy that, and we'll do that 2 more times. Goes 11, 12. Just for best practice, and it only runs once because it's in the setup. Alrighty, so what I'm going to do is I'm going to copy that, and down where we stop the song. So this is where we stop the song here, song.close. Underneath, to shut the lights off when we stop, we're just going to throw that in there so that it forces them down to low. And the only thing that's left to do is I'm going to grab one of those where we're specifying the kick size, the snare size, and the hi-hat size. This is where we just turn on the light. So we can actually write this as high. And we can grab this, do 11, grab this, go 12. And that's pretty much it. Now they will stay on. So we can go back up here, grab that. Because it's looping, we've set them on, but we haven't set them off when the song's playing. So just on the second curly brace there, we turn them off. And that's it. That's how to implement the Arduino side. So I can hit play. It does take a second because it's got to connect to the Arduino. And I will hit play, and then I will switch over to my camera. Yeah, so you've got it communicating with an Arduino, and you've got some lights going. If you did
so
that,
awesome,
and
Ben,
you're able
that's
to,
so cool.
you're able to follow through the whole time, I applaud you. If you got stuck, if you have any questions, if you want to see anything else, let me know. I know it was a pretty quick one. I know the time is, we're almost at 2 hours there.
Does anybody have any questions for Ben? Like they're related to Arduino, related to the course we all took, related to just going to school, anything at all? Related to the fact that my cat looks like a little Muppet right now. Any questions?
Can I just ask one thing?
Yeah.
I'm doing the Arduino course this semester, and we using an online version of Arduino. And I don't know if you guys ever heard of Tinkercad.
Yes, yeah, I have.
Uh, can I do something with that complexity with Tinkercad? It's because usually when we use Tinkercad, there's only one class, and we just go to that. Like,
Um, so you could, but it would require a lot more advanced webhooks. That's what it would use. So you would essentially have to run a listening server because it's a virtual Arduino, if I'm correct.
okay,
You would, yeah. So it would get a little bit interesting. I don't know if it has the full capability of doing that. Unfortunately, you probably can't do it
Is
easily.
is your teacher Maddie, or sorry, Matt Wilson, or
okay. Yeah, I'm person.
Matt?
Yes.
Okay, I'll send him this video. I'll send him a link to the video so that you can ask him and be like, I want to be able to do this.
Yeah, yeah. Okay, thank you.
Yeah, and it's mainly because we're controlling the Arduino with a Java program. And that's the hard thing about not having the physical hardware. Um, it's nice to see when you see it on the screen, and there's a whole bunch of other things you can do. If you really wanted to get complicated with it and you really wanted to dive in, the next thing, if you're musically inclined or you have some sort of knowledge, it would be getting a tempo. So where you hear that, like that kick going like in a tempo, I think that song was about 128, the Game of Thrones one. You could actually use this analyzation to check each band and see which one's going at a rate between, say, like 50 and 180. 180 is a pretty quick song, but you could check one and actually calculate for a BPM, which is a tempo, and then you could start doing some really cool stuff because you didn't have to hard code these values like we did, where we set like the snare trigger and the kick trigger, or we even set the bands. So you could dynamically find that, which I have yet to do. I've been busy, and I put together this for this little presentation, and that other complicated one that I threw together, that was also just done for this. I took this code that we just did and I kind of put it on steroids. So that one that I showed with the 16 channels, that was derived right from the code that we just wrote.
Josh, you had a question as well?
Yeah, sorry. Was looking at the bands as you mentioned, and I'm not too sure. I mean, I know you were just going over the code quickly for the project, but I wasn't too sure how exactly you got the bands. Like, what exactly were you able to get from the song to make the bands, increase and decrease?
So this for loop here, can you still see my screen or no?
Yep, I can still see.
Okay. So this for loop here, all this is doing is going from 0 to 80, or 0 to 79, and it's drawing out the band from left to right on the bottom of the screen. And because I'm setting whatever band goes above the value of 60, I'm setting it to red. It's a nice way to see what's a hot band. And essentially what I'll do is I'll just play it and look at the bands, and I do have a bit of a music background, so I'm able to tell kind of where the snare would be, where the kick would be. I didn't do anything for the hi-hat, but in the more complex one, I pretty much dynamically assigned the lead and the synth is what I labeled them. To get that value, it was a trial and error to get it exact. So if I play this and it's going to connect to my Arduino, so it might be a little bit slow. And if I do this one, hi-hat just goes because it's part of the function, but I'll look to see what band, and we can see 9 is right here. And when we see it spike there, it spikes pretty high, but 8 is also spiking. You could pick one or the other. So you could set it to whatever you'd like and it would trigger. You don't actually have to set it at those bands that I specified, but that's how I got them. I just looked to see which ones turn red and tried to narrow it down, and it's easier to visualize. So you could set the band to, I could set it to 8 and then watch the snare and see when it triggers. I listened for the song and I wanted to hear that like that happens every, I think it's 3 or 2. So if you're counting in your head, like 1, 2, 3, 4, it would happen on the 3 or the 2.
All right, so maybe I misunderstood because I have no audio background at all.
No
So
worries.
the reason why it's red, you're not doing it just because it's spiking. You're doing it because it's specifically the kick.
I'm doing it. I'm changing it red because it's spiking. Like if I change this to 120, let's say.
I wasn't sure if it was color coded because you have red as kick and green as snare and blue as hi-hat.
Yeah, that was just because the LED colors that I had.
Okay.
Which I don't know how well that came out on the camera.
No, I
But if
saw it.
we go back to here, they're only red because that's just what I had in my original code. You could change it to any color.
All right.
So any that are going to go over 120 now are only going to go red. So that's probably an easier way to specify, like, or to track down which bands are hot. And if you've ever seen like an audio spectrum, where you might see like on YouTube where you see all like, these are pretty much what we're drawing. And this is FFT. Starting from the left side, it's the low tone. So you get bass or like sub bass or your kick, where the kick is on a kick drum, it's going to be a low tone. So you'll find it here. And a lot of the time it's a lot higher volumes than what's up at the top. And very similar, like you can see that this is a GIF, I guess. And there's a lot of peaks. So those peaks are pretty good bands to pick.
Okay, I see.
Yeah, so it takes a little bit, if you want to get into it, it's good to track down and listen to some music that has a lot of low end and then throw it in here. All you have to do is go up to here. If you really want to, you could be lazy and just change the name of the file right here and hit play. And you could see how it plots out on our graph. And if you got like decent headphones, like, yeah, you got decent headphones, you can throw them on, crank up as much as you're comfortable and listen for that bass and you'll see it spike. Listen for any lead or anything that does like a melody, or listen for the snare where it's hitting them like it's a big crash.
All right. And one more question. So for the Arduino board, I see a red, green, and blue LED. But if you were to do something like the house you built, would you be able to just substitute that with LED strips as opposed to the single LEDs?
Yes, yeah. So the way I did the LED strip on the house is, I didn't get a good picture, but this is the strip that's right here. And that is an RGB strip. If you're looking to buy some, it's called a 50/50 strip. That's just the width of it. And it's got 4 contacts. One, I believe, is +5 or +12 for power. And then the other 3 are the colors RGB, and you pull them low. So with that is each color was actually a different band, and they were very similar. Yeah, there you go. Virginia's holding up a controller. So that's probably a controller that you can use with like an IR remote. Yeah, there you go. And each color has its own wire essentially that can go to the Arduino, and then you control that by each band. You can play around with it if you want. That it's a really cool way to see how it reacts. And how I got the colors to change on this, so on the front of the house, is it's based off the music. which is cool because each song that you load, it will show different colors. The light strip won't be the same color, won't be the same pattern, but in the same song you're playing, if it's repeating, like if the song repeats itself, it'll show the same colors if you slow it down. Which makes it kind of unique, and it's not pre-programmed or anything. There's no pattern. And that's what a lot of people think is when they see this, when they see the video, it's like, oh, you went through and like took all your time to say like at this beat, I want all these lights lit up. No, it does it by itself. I load a song, hit click play. And that's what I wanted.
Yeah, well, it's a really cool project.
Yeah, it was quite a few hours, and I'd say in materials and everything it was about $100.
He definitely went above and beyond what the rest of the class presented. I have to admit, there were like a couple really cool ones, but this was definitely one of those things that was just above and beyond the effort, which obviously clearly aimed him 100%.
Yeah, it was worth it, I think, just to show off, because I had a background, like I used Arduino since grade 9 it was. So I understood it going into the class. I understood Java and I understood processing. So it was, how do I make something that shows that I didn't just start this class? Not to say there's anything wrong with that. You got to start somewhere.
Hey, I just started that class and I did Conductive Fabric.
Yes, I remember
So
that.
it was when you pressed on the fabric, each different area of fabric that you pressed on would cause a key to be hit. So you could basically play a video game just by hitting the conductive fabric. It was really neat.
Oh, I can't
And that
even
was done
imagine.
through an Arduino, through a LilyPad, because we thought the LilyPad did the same thing as a Flora board. But the LilyPad doesn't have the keyboard H function in it. So when we went to try through that, it did not function. I thought I was going crazy with my coding, having it not working. And then I found out, nope, it was just what I was using didn't have the right stuff.
I think that's a good thing to highlight. I'm using Arduino. It doesn't have keyboard emulation. I think the Leonardo does, so that you could mimic a keyboard
Yes,
and
yes, it
send
does.
keyboard input, but this one does not have that.
Yeah, and if you're going to think of anything that's going to mimic keyboard input, you do have to like look that up and make sure that you're getting yourself the right board to be able to do it.
Yeah.
Yeah, all stuff again, the only chance I was able to use Arduino was from last semester's class on Tinkercad.
Right.
That was
Yeah.
my only exposure to it.
Yeah, that's the thing with COVID. It prevented a lot of in class, and that was the cool thing about that, is you get to see everything that people made, and people made like smart light switches. I personally, outside of the class, what do you got there?
This is the giant Smarza pack. You can get it for like $50 on Amazon. It has everything. If you're interested in just playing with like the clock modules and motion sensors and all the things, it comes with a whole bunch of pre-made stuff that you can just build. And then learning those basic things, you can start putting them together to actually make real functioning objects. It's pretty cool. So
Yeah.
instead of using Tinkercad, you actually get that that physical use of the objects.
Yeah, it's
Marma, you said?
pretty cheap to get into, like using the Arduino. Like I've got, I don't know how many Arduinos, and I've got like 10, I'd say, Arduino Nanos, which you have to solder to. But
Those are choice.
yeah, so that's another cool thing I have. And I have these little things called Wemos Minis. Let's see. And they have Wi-Fi built right into them. You can program them with Arduino.
Yes.
And it give you a few pins. They're really handy for doing anything over Wi-Fi. And the lights that are behind Virginia that she has set up there, I've built them, used this Wemos Mini, and they're all clients. and I used a Node MCU, which is another like a little board, very similar, just a little bit more powerful as the server essentially. And what I did was I read on the 3.5 millimeter jack, so like an audio, like an aux cable. I sent the signal to this, it read that and outputted this over Wi-Fi to the client light towers. So it's a little bit complex, but those lights, those RGB lights behind her, I've made those and made them wireless and fully wired with laptop batteries. So I took old laptop batteries apart and took the little cells to make a battery pack for them.
Yes. I can show you guys a website that is sort of my addiction. I have just piles of multiple things. I'll show you my little screen two here. We'll share that. So, oh my goodness, I just piled everything on there. Cool. So this is Adafruit. Adafruit is one of my favorite things. They have a whole bunch of really intricate but very simple to use different types of boards. So they have like the Cricut Playground Express. That's an amazing board to use. It's built off the floorboard, and then they built it into more of a wearable technology type thing. You can use so many of these. It has blogs as well. So if you want to learn about what the new stuff that they're coming out with and they're designing, these guys design a whole bunch of stuff. It's amazing. Then they also have the Learn section, which is one of my favorite things because you can learn how to build all sorts of things, all sorts of tools. The Cricut Playground is super cool. I have one of those, and I also have the Adafruit Feather with the blue fruit on it, which means it has Bluetooth capabilities. It's basically a place where you can look up how to do all the things and also purchase all the things for your stuff.
Yeah, Adafruit's it's a pretty cool website. Even if you're not using something like an Arduino, it's got little projects. Like I think the first thing I ever made, I was in grade 11 from Adafruit, was a TV Be Gone. And essentially it had a 555 timer on it that ran through IR codes that were shutting off TVs. So when you press the power button on your TV, it sends an IR signal. What this thing did was it ran through like thousands of codes within a second to shut off TVs. That's the only purpose it did. You press a button, it would shut off TVs. So you go to Walmart or something, and it's got the panels of like 12 TVs in a row or something like that. You press one button and they all shut off at the same time. It's funny to watch.
And everybody's scrambling. Why are the TVs going off? Why are the lights still on, but the power looks like it's gone off?
Yeah. It's
all sorts of April Fool's fun you can have with these things.
Don't recommend it, but I don't condone it. Don't
recommend it, don't condone it, but
I didn't tell you to go do it.
But yeah, so like there's all sorts of things that you can do with this amazing tech that we have available to us. And Ben, thank you so much for coming tonight and teaching us this amazing code, because I always wondered how you did it. I can always make LEDs blink. You can make a robot avoid obstacles, but figuring out how to code it with music was definitely something that I really, really enjoyed. So thank you so much.
No problem. Yeah, it's if you guys have any questions, what I will do is, well, you have my GitHub. What I'll do is I'll just throw my personal email there. If you guys ever want to shoot me a message, ask how I did it, ask if I can help you out with an Arduino or Java or something, just let me know.
There's also a question there from Raphael. What do you think about the Mega board versus Arduino brand?
The Mega board.
The Mega is an Arduino brand, isn't it?
Yeah. So I don't know if I have it. Let me see if I got it handy. Give me 1 second. Yeah, so I got a shoebox that I use.
We're both like, we have these things here. There's the Mega right there.
Yeah. So I have this is a little example of adjustable RGB lights, and it's a really dense strip. This is what I used for the lights behind Virginia there.
Oh, the dirts.
So that's a really dense strip. And it's only got 3 pins because it takes power and then data, which you can still drive with an Arduino. You just have to use the library called Fast LED.
So this is the kit that I had that I just keep for when I want to build something.
There you go.
The mega kit. So the mega board can do all the things. So it comes with all the things. Yeah, that's there we go. We got some nanos coming out.
So these are 2 Leonardo boards that are off Amazon. That's another Uno, that's a Mega, and this little guy is a Nano.
The nanos are what we use to do little robots. So once we hopefully get back on campus, we'll be able to do little robots night. And we're going to build our own little obstacle avoiding robots with a super simple code that face. Yeah, look at that little that is.
So that's the Wemos. That's the little
Wemos,
guy.
yeah.
Yeah. It's got Wi-Fi built right in, so you don't have to worry about adding like an ESP to it.
Awesome. Awesome. Thanks so much for joining us, guys. And I know that it was like a long day, especially for Ben and myself. We've been up since early 8 in the morning and working away. So thank you so much for joining us. If you do have any questions, either email Ben or feel free to email myself. I will be sending out the recorded version of this. Like I just put it on my YouTube for now. Oh my goodness, I'm so sorry. Eventually, we'll have our own little maker zone where we're going to post all those videos. But yeah, thank you so much for coming. And thank you, Ben, so much.
No problem. What I'm going to do is going to upload the code that we just finished onto GitHub.
Awesome.
That way you guys can copy that down and take a look at it. It does incorporate the Arduino stuff. So if you haven't gotten it running, but you do want to run it, I will make another one that like another folder that has no Arduino.
Awesome. All right. Is everybody good? Does anybody have any like last questions to go through? Because I'm gonna close the meeting and then it just disappears.
Well, I'm all good. Thanks again for showing off this cool project.
No
Awesome.
problem.
Thanks so much for coming, Josh, Alex. I think Raphael
Take care.
may have left. Yeah. Okay. All right. See you guys later.
See you guys. Thank you.
Bye.